Hello and welcome to this demonstration of the MarQ runtime verification tool. I'm Giles Rieger from the University of Manchester in the UK. This talk is a short demonstration of the MarQ tool. I'm going to give some background, overview the architecture of MarQ, and then give some brief demonstrations. These demonstrations, for time constraints, are relatively brief and simplistic. There are more examples on the project website, including the ones used here and these slides. So what is MarQ and where did it come from? Well, MarQ stands for Monitoring at Runtime with QEA, and QEA is a formalism for runtime verification introduced in 2012 by Howard Barringer, Klaus Hafland, Elias Facconi, myself and David Reidhead. And it grew out of discussions trying to find a middle ground between the expressiveness of the ruler approach developed by some people on this slide and the efficiency of the well-known Java mop approach. And what we have in the end is a very expressive formalism based on the theory of parametric trace slicing. Now, this isn't a talk about QEA, and there are other materials online and available in published work which cover QEA in more detail. I'm going to be talking about these three properties, relatively simple properties, written as QEAs. I'll explain them further when we come to look at how they're defined in the MarQ tool. The first two are to do with iterators, and the third one is to do with publishers and subscribers, and just shows off a complex quantification you can have in QEA. So I'm going to break down three uses of the MarQ tool and just give a quick demonstration of those. And the three uses are defining QEA to produce monitors, and in this scenario you define a QEA using a QEA builder and then pass that QEA object to a monitor factory which analyzes the structure of the QEA and builds a monitor which is efficient for the features we see in this QEA. For example, if the QEA doesn't use free variables, then the monitor produced won't be aware of these and has a little bit of optimization with that respect. Then there are two settings for monitoring: online monitoring, where we use AspectJ and produce a series of verdicts, and offline monitoring, where we take a trace, parse and translate that, and produce a single verdict. So that's what I'm going to demonstrate now, and let's go and have a look. So I've imported the QEA project, which is the base MarQ project, from GitHub. On the GitHub repository, there are also other projects to do with benchmarking and property specification for the competitions and things. There's a README file there, have a look around, and you can find lots of material. I'm going to use the QEA builder, which I mentioned previously, now to specify this safe iterator property. And the first thing I need to do is create a builder object, and I'm going to make this QEA at the end. And here I've written a specification of what the safe iterator property is, that if an iterator I is created from a collection of size S, then S is upper bound on the number of times next can be called an I. So the QEA builder approach is relatively low level, so I need to declare a few things, and the first thing I'm going to declare is declare my variables. So I need an I variable and I need a size variable. Now in MarQ there's an implementation reason that quantified variables need to be negative and free variables like size need to be positive. This is something which the user just has to remember, and we will make change in the future. And we also need to declare the events, so there's an iterator event and a next event, and we're going to declare the states. And I'm going to need two states here, a start state and a created state where the iterator has been created. And now we can start defining the QEA. I'm going to start by defining the quantification. Just scroll this down a little bit. So add the quantification of for all I. And I can now also define the transitions we need. So the first transition starts from the start state, takes an iterator event with two parameters, I and size, and ends up in the created state. And the second transition goes from the created state, takes the next event with parameter I, and we need to check two things. So we need to check that the size is greater than 0. And then if we take the transition, we want to decrement size. And this is a looping transition. And then the final thing we have to do is define acceptance. We're going to add both start and created as final states. Now this is property demonstrates the use of guards and assignment or actions in QA in a quite simplistic way. So here all we've got is the size variable, which we're checking in a guard and updating an action. There are examples of more complex properties. The guards and assignments in the QA project are all predefined for you. There's a lot of guards and assignments to do with arithmetic, but also to do with sets. You can add your own, you can ask me to add them. In the future, we want to introduce a language which makes it easy to add guards and assignments. We don't have that yet. And guards can be combined using Boolean operators, assignments can be composed. So this is the safe iterator property. We can do the same to implement the unsafe map iterator property. Now this is the standard property which you may be familiar with, that there does not exist a map, collection, and iterator, such that when the collection is created from the map, the iterator is created from the collection, the map is updated, and the iterator is used. And there are 4 events, and we have 3 quantified variables. We declare these quantification and the negation, which is important. Because this property captures the violation, so QA always capture validation, so we need to negate it. And the standard transition structure you'd expect. Now in this property we want to ignore events which don't take us forward because this is defined as a reachability property, and so we need to set all states as skip states, which means they skip undesired events, and this needs to happen right at the end when the builder is aware of all the states that have been used in transitions. The last property we define is publisher subscriber property that states that for every publisher there exists a subscriber that receives all messages published by that subscriber. So again we have 3 quantified variables, we have this complex quantifier alternation, and we have some simple transition structure. So I've now shown how we can define QEAs using MarQ, and then now we can see how we do some monitoring. And we're going to take a very simple example program. Now, this is a program that just creates and uses some iterators. So we're looking at the safe iterator and the unsafe map iterator properties here. And to monitor this program, we expect the user to write the SPECJ. So this is different from some programs that automatically generate the SPECJ. MarQ was designed as an outline monitor. But to do this, we just define our point cuts and our advice. In our advice, we just send the event information to the monitor, and we get a verdict back which we can check. We also need to construct the monitor, and this is using what we just wrote, and construct. This is the QEA, this is the monitor, using the monitor factory I mentioned earlier, which constructs an optimal monitor for that QEA. And here I've got a little check function which checks a verdict, and in this case I'm just printing a warning, but you can do whatever you want here with the verdict. The important thing here is that these event integers match those in the QEA, And in this particular example, I'm using a lock to synchronize access to the monitor, as monitors by default are not internally synchronized. We can do the same for unsafe map iterator. In the standard way, we have a set of point cuts, a set of advice, and then we can run the program. And as we can see, we have two warnings that the program has violated the two properties. I've designed it so on the same event both properties are violated when we hit this next for the last time. And this is a relatively large program. We've got 100,000 iterations, so still a relatively trivial workload, but checked instantly. So this is online monitoring. It's relatively straightforward because we have the separation of concerns between the instrumentation and the monitoring itself. Now let's go have a look at offline monitoring with MarQ. I have a trace here for the publisher subscriber property in a CSV format. So the CSV format we use is from the competition, except for the fact that I haven't included a header file because this doesn't seem to make much sense. We take event name and a comma-separated list of values, and then we have a CSV file monitor which will parse that. We also have file monitors for XML and JSON from the competition formats. And this requires three things: the trace, and I've just defined where that is, the QEA, which we wrote earlier, and something called a translator, which maps events in the trace to events in the specification. Now here, these events look very similar to the events we had here, and all we need to define here is a default translator, which is the case where the number of parameters and the order of parameters and the types of parameters are exactly as they are in the specification, and there we just need to define the order of events. So this is event 1, event 2, and here we had event 1, event 2. And I can run this, and I'm told there are 5 events and there was a failure. Now this is it's not a safety property. We only know it's a failure at the end of the trace. So there's a finite trace semantics for QEA. So all we know is that it failed, and if we look at this, we can tell why. There's a message which hasn't been acknowledged by anybody there. Now the trace might be a bit more complicated. It might contain extra information, so we might have to pick out the identifiers for the publishers and the messages from this list. And here they appear in positions 1 and 3 for both send and acknowledge. And we might have these extraneous forward events in there as well. So we can create a more complicated translator in this case. Just change what's written there. And this translator defines the columns in which the parameters appear, so columns 1 and 3. And it also says we can ignore stuff which doesn't appear here. That's not an error. We'll just skip over it. So now we can run this. Oh, I want to change this to the second trace file. Now we can run this again. And there are 10 events this time, still a failure, but we don't know which 10 events were monitored. And so we can tell the translator to print the events. And then we can also just get the information that was extracted. So perhaps things are looking a bit odd, you haven't extracted the right things, you can view what the monitor is seeing by doing this. Something else we can do with the translator is we can parse things. So if we take the safe iterator problem and a little trace here where we've got integers which represent the size of the collections, we can tell the translator about this, and this time we use the translator factory to make a parsing translator which will parse the parameters. And if you take a look into the translator factory, there's all sorts of different parsers and translators defined there. And now we can run this, and this is a safety property, so we're told on which event it fails, which is the 11th event. There are more than 11 events here. The 11th event is this one here. So that's the second call to next on the iterator C, which should only have had one call. We can also give it larger log files. So this log file had just over 2 million events, and it was fine. And the monitoring efficiency scales relatively well. Okay, let's go back to the slides. We've had a very brief demonstration of how to define QEAs, how to monitor programs using aspect J and MarQ, and how to monitor log files. I mentioned along the way that MarQ is reasonably efficient. We've had some success in competitions and there are experimental results published. It could be better. There are extensions to things like indexing planned. There are also improvements to usability needed and planned, so a better domain-specific language for defining QEA, a language for defining guards and assignments, perhaps automatic generation of aspect J, if that's really needed. And there are other plans for the future, including translations between QEA and other RV specification languages, like rule systems, temporal logic, Java MOP specifications. Okay, thank you for listening, and if you have any questions, probably best to direct them to me via email.